Number 35 says find dy dx by implicit differentiation. What this means is we're going to find the derivative by not solving it explicitly in terms of y equals, but by just taking the derivative of both sides of the equation as is. So that's what we're going to start out with. We're going to take the derivative with respect to x of both sides. Okay, so we're going to take the derivative of each piece inside here. For instance, the derivative with respect to x of 2xy minus the derivative with respect to x of y squared equals the derivative with respect to x of 1. Now when we take the derivative of this stuff in the 2xy, we're going to actually have to be using the product rule. So this piece here would be the first part, and this piece here would be the second. So here's how it's going to break down. First, 2x times derivative of the second. Derivative of y is just 1, but with respect to x you have to include the dy dx. So it's 1 dy dx. First times the derivative of the second plus the second, y, times the derivative of 2x, which is 2. So this is how I'm getting this information from the product rule. Okay, then we got to take the derivative with respect to x of y squared. So we have minus, that will go 2y dy dx equals 2. On the other side, the derivative of a constant is just 0. So equals to 0. So let's rewrite this a little bit different. This will be 2x dy dx plus 2y minus 2y dy dx equals 0. Now I'm going to move over, subtract over the 2y from this side, and we can also, since these are the only things that are going to be on this side once you move it over, we can factor out the dy dx, bring it to the front, and we'll have a 2x minus 2y equals negative 2y. Now we can divide both sides by 2x minus 2y. And what we're going to get here is dy dx is negative 2y all over 2x minus 2y. And the only other thing we can do is notice that there's a common factor of 2 in the denominator that we can factor out, reduce with the numerator, and simplify this to be dy over dx is equal to negative y over x minus y.